In this video, we're going to look at the idea of an average value of a function. So before we get to a formula, let's talk about the idea of what an average value of a function would actually be. So I've got a picture here of a wave making machine in a fish tank, and you can see that on the surface of the water, along the edge of the wave, that we actually have kind of a function thing here happening, and we could almost have this is our x and y axis here. And if we looked at the values of f of x for this particular curve here, it goes up and then it comes down, and then it goes up and then it comes down, and then it goes up and then it comes down. If we wanted to know the average of all of these particular values, what we're looking for is kind of like the equally shared value. So what would happen if we turned this wave machine off is that the water would settle, and it would settle somewhere between the highest height and the lowest height. And that area where the water would settle is what we call the average height of the water. And so we use the same idea over here with this particular function, and if we're finding the average value of the function between this x value and this x value, so what is the average of all of these y values? It's going to be somewhere between the highest value and the lowest value. So what on earth would we use this kind of thing for? Well, we actually use it quite a lot when we're modelling situations and we want to know an average for a function. So here's a question. It's a little bit contrived, but anyway. The number of people living on a small island can be described as n of t equals 100e to the 0.005 t, where n is the number of people and t is the number of years since 2010. Find the average number of people on the island between 2012 and 2018. Now it starts to make a little bit of sense. This function is measuring some kind of property of the number of people in the island, and we want to know what is the average value. So let's dip in and have a look at this idea of leveling a function to find this average value. So what you're looking at here comes from a website called Desmos, and it's trying to show you the average value of a function. And so what it's doing is we've got an area under this blue line here, and so we're going to look for the average function between 1 and 9. So we're going to take the total area that's in this hump and kind of level it out. Can you see it's leveling out? And when all of this stuff that's too high is transferred over to the other two sides, what you get is an actual average value across here. And so this value here, which is about 10.5, 11, is the average value for the function. So let me just go back. Let's have a look at this one. You can see that there's some areas the function starts out with area above, like that. And then if you slowly drop it down, it levels off to a line, and it is our average value for the function. So I'm going to just skip back once more, and I want you to have a look at this particular function here. And if you had to predict where the average value would be, and by moving this particular line up, where would you put it? What do you think the average value would be? Somewhere around here? Around about 10.5? What about this next one? What about this one? Where do you reckon that would end up? how high up would this line need to move to be the average, where the stuff that's sitting up above can be distributed into these holes below. So hopefully now you're starting to get the answer here is 13. Hopefully now you're starting to get the idea of what an average value of a function actually is, and that we're actually going to use this idea of the area below the curve, distributing this area below the curve equally across the whole section that we're working with. So let's have a look at that. So our average value for a function takes the area underneath the curve between 2 points. It keeps the two terminal points exactly the same, but it shares this area equally, so you end up with some kind of line, some kind of level, and that level, that y value, is your average value for the function. Okay, so let's have a look at what we've got here. The area under this graph here is a rectangle. So we know it's length by width. So it's going to be b minus a times this height here, which is your average value for your function, your y average. And this area here, we know we can find that area by integrating the function between a and b. So we have two formulas for the area. We have our integral area that does this one, and our rectangular area that does this. Now we know these two areas are in fact the same, and so we can make this area, which is our integral, equal to this area, which is our rectangle, and that's exactly what we do next. So we've got our area under our curve is equal to that rectangle when the curve is flattened out and given an average. So if we rearrange this by dividing both sides by b minus a, we'll get our average y, our average value for our function by itself. Now the formula that you'll see in the textbook doesn't have this integral divided by b minus a. It's actually got it multiplied by 1 on b minus a. So it looks like that. And that is your average value for a function formula. Now it's not on the formula sheet, so it's something that you need to remember and something that you probably should have in your bound book. So let's go back and do this question that we started off with at the start. So we've got our formula that we've already highlighted. Where's my highlighters? So we've got the number of people. Here's our formula. We'll highlight that, where n is the number of people and t is the number of years since 2010. Since 2010. So we need to find the average number of people on the island between 2012 and 2018, remembering that it's since 2010. And then finally, we need to give our answer correct to 3 decimal places. All right, so let's deal with our 2012 to 2018. So 2012 is 2 years, so t equals 2. 2 years past 2010, and 2018 is 8 years past 2010, so t is equal to 8. So we're going to use our formula here, sticking with the notation that we've got up here. So we're going to have our average n of t value, and our derivative is going to be with respect to t. So our formula, when we fill it in, looks like that. And I've just used the subscript average down here, the same as I used the y average to give us our average value. So I'm not going to try and calculate that by hand, so here's one I prepared earlier. I've done it on my CAS calculator, and correct to 3 decimal places, the average number of people on the island is 102.535. Now, because it's an average, it doesn't need to be an exact number of people. And in terms of whether you round people up or you round people down, what to do in the exam, the people who write the exam are very aware of the difficulties with do I round up and do I round down, so they will give you a direct instruction on what to do. It'll say round up to the nearest number, round down to the nearest whole number, etc., etc. So don't worry yourselves about do I round up, do I round down. Just follow the directions that they give you. This one says 3 decimal places.